Hello, everybody. I'm going to present myself. My name is Carlos Moreno from Venezuela, Universidad Central de Venezuela. One second, please. Let me check something here. I'm very glad to be here with you. Okay, good morning, everybody. My name is Carlos Moreno from Universidad Central de Venezuela. The name of my presentation is Study of the Effect of Security on Quality of Service on a WebRTC Framework for Video Calls. This is the result of collaboration between Universidad Politécnica Salesiana de Ecuador, IT Business Solution, an enterprise from Venezuela, and University Sliet from India, with my colleague Vinod Kumar, who presented yesterday. The points of my presentation are the following. First, motivation. Second, state of the art. Third, formulation of the problem. 4, methodology. 5, results and analysis. Next, conclusions and perspectives. Then publications, previous publications, and we will have a few minutes for questions. So let's begin by saying that during the years 1990 until 2021, there has been a process of convergence where traffic of video, voice, and data are sent over the same platform. And some protocols have been created for that on signaling. For example, H323 from ITU. We also have SIP with the IETF over IP version 4 protocol and IP version 6. And we have some peer-to-peer architectures, which they represent de facto standards. And we also have WebRTC, which is an architecture created by Google and is being standardized by IETF and W3C. And this is the focus of our study. And we have to take into account the quality of service and cybersecurity nowadays. But the question is, which is the relationship between these two aspects when we have an architecture that works with WebRTC? This architecture can work on an NGN over Wi-Fi, over 4G, 5G, 6G, and eventually next generation cellular networks. So regarding the state of the art, we have to remember that in quality of service, we speak about latency, jitter, packet loss rate, delta, which is the separation between frames, and response time. By the other side, we have in security, confidentiality, authentication, integrity, non-repudiation, which is the relationship between these two worlds. When we speak about WebRTC architecture, we have two planes. At the left side, we have the signaling plane when we use even TLS for ciphering, integrity, and other aspects of security. And on the right side, we have the media plane, which contains the video, audio, and even data channel for data. And we can use DTLS, which is the complement of TLS for protocol of transport layer, UDP. This is in that standardization process by IETF and W3C, as I said before, and it was created in May 2011. Some work has been done trying to relate quality of service and security, but it's not enough. It's very general. For example, on the first paper, the security is contained into the quality of service on the modeling process. On the second paper, they use a KNN file classification to establish levels of security and how they affect the quality of service, but in general. And on the third paper, they study when they implement security over a cloud, how is the effect, which is the effect. And 4, on cognitive radio networks. We also have 2 studies, important ones. The first one is which factors influence the quality of experience, because we have to differentiate quality of service with quality of experience. Quality of experience introduces more elements, you know. And on the second paper, on this slide, we have how to measure the quality of service. These 2 issues are more important. We also have some standards which have been proposed, a recommendation by the ITU regarding quality of service and security. But regarding quality of service, the most important one is this, is the Y1541. Objectives of network functioning quality for Internet protocols-based services. The question is, the parameters of quality of service, do they comply with the standards? We have two research questions. First, how does security affect quality of service indicators in LAN and WAN WebRTC scenarios? The second question is, do quality of service indicators maintain within recommended values when assuring signaling and media traffic on WebRTC? Context, we have 4 test beds, 2 over LAN, 2 over WAN infrastructures. The WAN infrastructure used was the main ISP from Venezuela, which is CanTV, with DSL access technology. Results analyzed by my team group from Venezuela, Ecuador, and India. And we have now the methodology. We have 4 test beds. The first test bed, the first scenarios, number 1 and number 2. We had the easy RTC framework of WebRTC installed over Node.js on the server. It's a signaling server. We use Google Canary from, we established 25 calls per security level from left side to right side, from a PC to a laptop. And we had 25 on every level of security. Which are the levels of security? First, without security on higher levels, of course, because we are using WPA2 on layer 2 security. Layer 2, TLS signaling. When I mean level 1, level 2, level 3 are levels of security on higher levels, right? Okay, third level, TLS signaling. And we also have DTLS on media. On the second scenario, we have the same configuration, but the difference is that we have a smartphone at the right side. We are using the standard N of Wi-Fi. So we established these 25 calls on these 2 scenarios, and we measured response time, jitter, and delta max. Delta was the separation between frames, and max is the maximum. We use Wireshark as our tool. Scenario 3rd and 4th is the same configuration. The difference is that we have the DSL access network on both sides. We also have 3 levels of security, 25 calls per security. On the right side, we have the scenario number 4, the same configuration, but we have a smartphone with the same characteristics as in the LAN infrastructure. We also use Let's Encrypt for certifications. These test beds could be seen on this slide. We have the first level of quality of security, second level of security, third level of security. We measure the establishing time from the moment when the first message is sent and when the first packet UDP RTP are received. We did the same thing at level 2, the same thing as level 3. For leaving time, we did the same thing. We measure from the last message, stone binding, when we received the last UDP RTP message. We did the same thing with every level of security. So we arrived to the results and analysis. The first thing that we have to say is that regarding the average establishing time, we can see that the second scenario and the fourth scenario are the worst. And they correspond with the use of Wi-Fi. So Wi-Fi introduces, of course, these characteristics. But, however, we can see that on the second scenario, when we use DTLS on the media, on the third level of security, the response time is better than on the second level of security. So somehow, the introduction of more security improves the establishing time. So the question is, what's happening? Well, we have to say something. TLS and DTLS complement themselves somehow. And they could introduce a buffering effect, because when we're ciphering, we need to organize the bits So it helps quality of service somehow. It's our hypothesis. And in liberation time, we have the same behavior. Of course, on the fourth scenario is the worst because we introduced the effect of the WAN and of the Wi-Fi. Regarding the average with jitter, we can see that on all scenarios, jitter is improved. According to the recommendation Y1541, it should be lower than 50 milliseconds, according to classes 0 and 1. And according to the best practices, it should be lower than 30 or 50 milliseconds for video, or lower than 30 milliseconds for voice. What's happening here? Somehow the jitter is improved. Perhaps it's because we're using some protocols which introduce also some buffering effect, because buffering is the way of compensating the jitter effect. And we also have the max delta, which is worse in the case of video. So the question is, what's the relationship between max delta and jitter? According to some white papers, they are correlated. And so we arrive to the conclusions and perspective. First, we can say that relationship between levels of security and quality of service depends on indicators and protocols for a scenario study with easy RTC. Second, security over signaling plane influences time response, while security over media plane influences response time, jitter, and separation between the consecutive packets, which is the delta. Third, quality of service indicators are within limits recommended by ITU and best practices for scenario study. Of course, we have to take into consideration the quality of experience, because we could listen well and see well. Delta max is more effective on video traffic than on audio traffic. Of course, if we use Opus and BP8 codecs respectively for scenario study. K-means can be proposed to detect clusters. We can separate into groups of study. The first one to study the time response, and the second one to study jitter, delta max for each of 3 levels of security on both groups. Similarly, with other additional indicators like packet loss rate, end-to-end latency. And also, finally, we should consider the study of different codecs for audio and video, because there's some relationship. 2 publications, previous publications, which were the beginning of our study. One of them was this study over an architecture that uses SIP protocol, where we demonstrated that the use of WP82 increases the joining time, but decreases the leaving time. So there's some effect of security on link layer. And we also have my colleague Kumar, which is here on this presentation, and our friends, our colleagues, we all had a special issue of Internet of Things. We could extend all these concepts to the world of Internet of Things, and we have a lot of things to do about cybersecurity on Internet of Things. So I'm so glad to arrive to this moment where we can have some questions. I'll be very glad to answer any question. Thank you, everybody. Desconectó. ¿Qué pasó?
Hello, Dr. Moya. We cannot hear you.
Okay, are you there? We finished.
Yes.
We finished. So we arrive to the questions. Do you hear me? Hello?
Hi, Dr. Moya. We cannot hear you.
Hi,
Yes,
okay, I'm sorry.
finished.
You
We
hear me?
finished.
Audible.
We
Okay,
finished.
okay.
Okay, so we
Okay.
have questions.
Yes, I have question.
Yes.
That's very short. If there is no question, I have question for Professor Carlos Manuel Moreno Norin.
Okay.
Believe is us more why amine clustering method can improve the detection on security level. You can see my question in the chat box. Do you hear me?
Excuse me. No, yes, I hear you, but I don't understand the question. Would you please? Okay. Explain us more why K-means clustering
K-mean
method.
clustering method
Okay.
can improve the detection.
Yes, of course. Normally, some previous work have demonstrated that there is a relationship between two quality of service indicators. There are a lot of work, okay, about that. For example, jitter versus packet loss rate. Some of these studies have been done in the past with simulations using Markov chains, for example, okay? And but they don't consider the application of security. We also have some studies that consider the effect, the security over the traffic, okay? But there are no studies which consider the relationship between two words, and specifically on WebRTC, which includes a lot of security because we are using TLS for the signaling and DTLS for the media playing. So if we could select the features on the first group, as I explained on the slides, and we could choose features for the second group, okay? On the first group, we could study how two features, which are the response time regarding joining time and leaving time, these could be two features, and we can do that on the first level of security. We could do that on the second level of security and also on the third level of security. So we can have three graphics with x-axis and y-axis, and we can detect if we see any clusters. We already did some of this, by using Weka, which is a software created at the University of Waikato. But until now, we found two clusters on the first scenario, but it's a work that has been done. And on the second group of experiments.
Okay, thank you.
So thank you, Professor Locke. I'm the partner of the Professor Carlos, and I would like to also add on something regarding k-mean clustering. So my voice is audible, I suppose.
Group. That is the method that we can use to detect cluster. But of course, the question is if we use the elbow to know when to stop, because that's the way of using k-means. Of course, we could use the elbow, but we can also visualize with the number of, of cycles with k-means. It's a proposal that we have taken into consideration for our perspectives. Did I answer your question? Yes?
Yeah, okay, Professor Carlos, okay. And apart from that, I'm answering the same question on the behalf of our presentation to the organizer,
Okay. Dr. Rino.
Yeah.
Hi.
Yeah.
Do you have the same question? Yes?
So, no, everything is okay, so thank you, Professor Carlos, for your nice presentation for our joint work.
Okay, thank you very much.